video, we were going to solve one simple problem from Chapter 11, Combination of Conduction and Convection of Thermodynamics. Consider a flat plate solar collector placed the roof of a house. The temperature at the inner and outer surfaces of a glass cover are measured to be 28 degrees Celsius and 25 degrees Celsius. Respectively, the glass cover has a surface area of 2.2 meters squared and a thickness of 0.6 centimeter and a thermal conductivity of 0.7 watts per meter Celsius. Heat is lost from the outer surface of the cover by convection and radiation with a convection heat transfer of 15 degrees Celsius. Determine the fraction of heat lost from the glass cover radiation. So this is the given of our problem. The thermal conductivity is equal to 0.7 watts per meter Celsius. The surface area of 2.2 meters squared. The temperature of 28 degrees Celsius, 25 degrees Celsius, and 15 degrees Celsius. The glass covered thickness is 0.6 centimeter or 0.006 meter. The convection heat transfer coefficient, which is 10 watts per meter squared Celsius. So this is the formula that we're going to use to determine the fraction of heat lost from the glass cover radiation. First, we're going to solve the rate of heat transfer by conduction. So this is the formula that we're going to use. The thermal conductivity, which is 0.7 watts per meter Celsius, multiplied by the surface area of 2.2 meters squared times the temperature difference, which is 28 degrees Celsius minus 25 degrees Celsius over the thickness of the glass cover, which is 0.006 meter. Cancel out the unit. The rate of heat transfer through the glass by conduction is 770 watts. Next is we're going to solve the rate of heat transfer by convection. So this is the formula that we're going to use. The convection heat transfer coefficient, which is 10 watts per meter squared Celsius, multiplied by the surface area of 2.2 meters squared, times the temperature difference, which is 25 degrees Celsius minus 15 degrees Celsius. So cancel out the unit. The rate of heat transfer from the glass by convection is 220 watts. Under steady conditions, the heat transfer through the cover by conduction should be transferred from the outer surface by convection and radiation. So this is the formula that we're going to use to determine the rate of heat transfer by radiation. Is equal to the rate of heat transfer by conduction, which is 770 watts, minus the rate of heat transfer of convection, which is 220 watts. So the answer is 550 watts. Then the fraction of heat transfer by radiation becomes the fraction of heat transfer equals the rate of heat transfer by the radiation, which is 550 watts, divided by the rate of heat transfer by conduction, which is 770 watts. So the final answer is 0.714 or 71.4%.